The wood of the day. It's not really a specific species, spruce pine fir, but spruce pine fir, here we go, we can pass it around. We'll start. Is very common here in Michigan, seems to be. All these piles of wood that are outside the back of the building are mostly spruce pine fir. All the stuff that Arash has been using in his construction downstairs is all, in fact, I think these are probably pieces of it, spruce pine fir. And spruce pine fir is, what is spruce pine fir? Well, it's a combination of spruce, pine, and fir. And if you look in here, in the list of what all this stuff is, spruce pine fir. Well, there's also a spruce pine fir south, which I don't think we have up here, but regular spruce pine fir is alpine fir, balsam fir, black spruce, Engelmann spruce, jack pine, lodgepole pine, red spruce, and white spruce. And apparently there's not much difference in the structural properties of any of those. That's why they're all grouped together. And they all, I mean, look pretty much the same, and it'd be very difficult to really identify which of those species we've got in our hands back here. But they, I mean, just so you kind of have an idea of what spruce pine fir is, you can see it's a very light, generally much lighter color than, I should have brought up the piece of Doug fir. Doug fir is a little bit darker. It's the other one that's used quite a bit in construction. Doug fir, I believe, is a little bit stronger. Should have checked here. You can check in the MDS. But spruce pine fir, yeah, is a pretty good structural member. And let's see if we got some pictures of it here somewhere. Yep, that looks like the pile outside, or down in the Fab Lab downstairs. Looks kind of like that, a little bit droopy, isn't it? I think this is an Engelmann, isn't it? Yeah, it says up here. Engelmanni. Peachia. I think that's pine. Not quite sure. At any rate, it grows pretty straight and pretty tall. Has short needles like a fir, so that's typical of a fir or spruce. I think they both have short needles. The pine generally has the longer needles. Yep, looks a little bit like that. So I think, is that all the images I have? Nope. Oh, one more. Something like that. That almost looks like a blue spruce, doesn't it? But that's not in the group. Yeah. Okay. So that gives you a little bit of idea of spruce pine fir, what that's about. And now, what we're going to go through is I'm going to show you how to use STAAD to do some analysis of wood. And STAAD is particularly, it's a very practical program. It actually gets used, according to their, what I've read, it's probably worldwide the most used program in engineering offices, because it's very, it has built into it codes from all over the world, not just the US codes, but all the European codes, the DIN norms, and the whatnot. It also does specific design of the materials, concrete, steel, and wood. It doesn't cover masonry. I don't think they've expanded it that far yet, and it's been around like forever. It was one of the original players in this game. Goes way back. In fact, I've used it for age. I used to have a copy of it on a reel-to-reel disc, believe it or not. It was certainly one of the ones that was most, that was designed to be used very early on. As opposed to a research tool. Like, to be honest, ANSYS is much more powerful, but it's, and has a whole list of different elements that it has built into it, and it has more capabilities in terms of some of the analysis, but it's not as, I guess, practical in terms of just solving a building construction problem and giving you, pass-fail of what you really want to know. STAAD does that. Since it does have the codes built into it, you can, put in the member properties of the actual wood type and species. The exact properties are actually in tables that you can pick, and it loads it into it, and then it'll do a pass-fail analysis of those members that you select. It'll also, which is even better, or sort of better, it'll select members for you. So you can specify, like, I want to do this with glulam. In fact, actually, that's the only one it does. If you pick the grade and the type of glulam you want, then it'll find the size for you. It'll select the size. It's with wood is kind of the orphan, I guess, of the three, steel and concrete. With steel, it does a fantastic job because it really will go through. You just give it the shape, and it'll find the member you want. You can specify the steel grade and all sorts of stuff, and it does a very thorough code analysis. With concrete, it'll also do a pretty good job. It'll even give you your reinforcing patterns, I believe. Pick the amount of reinforcing you need. With wood, it's a little bit, they seem to put the least effort into wood. It's, first off, not quite up to date in the code. As you'll see when we get to doing the code analysis, it's using an much older code, but that doesn't really make that much difference. So that the solution, and it only selects glulam. It won't do dimension lumber by selection. It will do a pass-fail on dimension lumber, and it does have all the dimension lumber properties, species, and whatnot built into it. So that's good. You can select it. So it works a little bit better as analysis than it does in terms of design, but it's still pretty good. The alternative to this would probably be a program called Woodworks, which is put out by, I don't say Wood Products Association, but I think it's Woodworks is maybe their own independent thing. And that is specifically, from the beginning on, designed to be designed with wood, but it is maybe a less capable finite element program. To be honest, I haven't gotten into Woodworks real thoroughly. Maybe I should sit down and do that, and we could look at it too. But STAAD is probably the more general engineering tool, and would be something you'd be more likely to run across in an office because it's used for other things too. The steel and the concrete, right? Okay, so having said that, we're going to, as an example, design this little floor system. So it's got these. This is supposed to be like a. In fact, I think it originally came from somebody's project. This is a floor on the right here. This part. Well, is that your right? Yeah, that's your right. It's a floor over there, and then it has like a carport next to it. So you've got both roof loads and floor loads, which won't make too much difference in our analysis actually. But that's it, and we'll go through and design the rafters and the joists as dimension lumber, and then pick all the beams as glulam members. You can, by the way, oh shoot, I meant to bring this up. you can get this software for free as a student edition from Bentley. Let me see if I can give you some input there. If you go to our great little website here, and I mean, just as a place to start, you can get there from anywhere. This is a link to the architecture page. This is a link to Michigan's page, by the way. So, can I get there? Ah, yeah. Except that, look, yeah, no, that came up right. Okay. No, it didn't quite come up right. Okay. I've got to, they changed the name of the web page, so my link's out of date. Okay, so here's architecture. And if you go over, somewhere, here we go, resources, there is this little section called computing. And if you go down computing, somewhere they say software, don't they? SAND Lab. Oh, good grief. Oh, here. Sorry. Probably on the side here. It says software. Okay, over on the side it says software. And if you click on that, it shows you all the software that's available through the school. And if you go to Bentley products, it'll send you to Bentley's page. Bentley bought out STAAD. STAAD was originally REA, was that the name? It was a independent group. I mean, from the beginning, they were somebody else. They were the STAAD group. And then Bentley eventually bought them out. Not too many years ago. Okay, so this is Bentley's page, and it seems like you can log in as a student, maybe. And if you go down somewhere, it's got software. It says software up here. Maybe that'll get us there. Did I get that? No. Come on. Okay. Whoops. Products. Okay. This is hopeful. Somehow we don't have the best connection here. Got kind of weird pages. And these are all the things you can get as a, MicroStation, of course. And this would be STAAD Pro. And you can download a copy. I think you probably have to register as a student somehow. I imagine they'll want your student ID or some sort of something to prove you're a student. I'm not quite sure. But that, you can get a copy, and you can use it then for this. If you, the other alternative, we have a computing lab almost directly below this room. It's downstairs, and that has like 20 computers in a lab, and they're all loaded with STAAD Pro. So that would be, if you want, you don't have to load it on your own machine. You could just go downstairs and use it. But that's how you get access to it. Okay, so we can get rid of that. And now I started it, opened the software just before. I mean, you just type STAAD and you get it. But when it comes up, this is what you see. Oops, come on. Okay. Let me see. Maybe I'll even make this big, huh? So apparently these are a bunch of programs. I mean, it keeps a list of them that you've done recently. What you would want to do is probably start a new one. And you just kind of answer the questions here. File name. Ooh, shall we give it a name? How about wood floor. Okay, and it's going to drop it on my desktop. Not a good idea. STAAD, in the process of running, it generates a slew of little files. So if you just dump it on your desktop or some directory, it's going to fill it with like 20 different files, which is just a mess. So it's probably better to give it its own little place to go. Am I on the desktop? New folder. Let's call it did I name it? Okay. Okay. And then select there. Okay, so I think I got it. Yep. Okay, so I'm going to drop it into a special folder. Analytical, that's what you want by default. English, we'll stick with English, not metric. And you could fill out, if you wanted to, you could fill out job info. Only maybe what you should do is put your name on this somewhere. I don't care where, but somewhere. Engineer, maybe engineer. Okay, you could do that. How about that? And that should do it. I mean, you can fill out if you just want to have fun. This information gets stored, and then it automatically would be printed at the beginning of a report that we're going to generate at the very end. So if you want, you can, or you can always enter it later too. It doesn't have to be right then. Okay, then I believe we probably want to hit create, and boom. Now we're in the STAAD regular space. And it's divided into, I guess, 4 parts. First, the workflow on the side here. These are the major components that you work with. I mean, you can see you can do very specific types of analysis. You know, if you're working on bridge decks, foundation design, steel design particularly, concrete design, no wood design, earthquakes. So it has all those special modules. We just want the first one primarily, analytical modeling. That's just the basic setup. So we'll use that, and then after we have everything inputted, then there is a post-processing that has a few added features that make it nice to look at after you've analyzed it. But we'll just start with this first one. Okay, so that's the basic category where we are, and that, when you select that, it gives you a breakdown in this bar here. These are the components that belong to analytical modeling. So if I went to something else, post-processing, it would tell me I probably I haven't made anything yet, and it threw me back. Okay, all right. Physical modeling? Okay. Oh, I don't have these components loaded, maybe some of them. Anyway, if you picked on one, it should give you a different set. When we get to, after we do an analysis, we will be able to go to post-processing, and it'll let us see different things up there. Okay, so then the next part are the menu across the top. That gives you commands that you use, and you usually, that changes slightly depending on the module that you're in, but these are where your basic commands are. So, you know, if you want to save it, probably it throws you back to here, and you could save it, right? You'd probably say, I haven't done anything. Okay, all right, forget it, whatever. And we'll work through these. You know, the loading has specific problems. I mean, commands that might go with the loading, the geometry. Your view is kind of nice. You can set view things. So those all go with that. You'll notice when I click them, they often change over here. Didn't that time? Oh, I'm still stuck on loading. But when you issue a command, the details of the command come up here on the right-hand side. So most of what you enter is over here on this side over. And it's usually, as you'll see, a two-step process. Usually you specify what you want, and then you give it its attributes. So you say, I want to add a beam, and then I got to say what the beam's made out of, or something like that. So it's usually and then you attach it. So, okay, well, anyway. But there is kind of a logic that the commands follow. There is a kind of pattern to it, as you would hope. Okay, so to begin with, we got a blank table here. We could draw the whole thing in in STAAD. That is possible, but it's a bit of a nuisance. Like most programs that are not CAD programs, if you want to draw in it, you've got to almost enter the coordinates of each point that you want to enter. You can do that, but it's far easier to import it. And let's see if I can get that to work. So I go back to this files. Here's my import, and here are the options of files I could import. Most common being a DXF file. So DXF is the drawing exchange format, right? This is AutoCAD's original exchange, and almost a lot of different programs. So you could be in Rhino, you could draw it up in Rhino, and you could export it. You have to be a little bit careful because although you can export a DXF file, it only reads in actually 4 elements. It'll read in lines. Well, it'll read in points being the nodes. It'll read in lines, which connect the points. And those are actual line elements, not spline, not curves, not other, because there are a lot of different things that look like lines in AutoCAD, but they're not lines. A line is a specific type. It's a line. So there has to be a line. It does do plate analysis, so it will read in from AutoCAD. It would read in a 3D face is what becomes a plate, and it'll also do solids analysis. We won't get into that, either one of those, but it'll read in a 3D solid. So it'll read in those, was that 4 elements. And I was very careful when I drew it in AutoCAD. I drew it just with lines. Of course, lines do have endpoints, although you don't draw them. They're there, so it'll read in the endpoints of those lines as well as points. They come with it. If you just you can create random points in AutoCAD, right? You could read those in, but they'll be unattached, right? They'll just be floating points, which you really probably don't want. It's best when you create your drawing in AutoCAD to clean it up first before you import it. Cleaning it up meaning limit it to only lines. If you've got splines, you've got to convert them into lines. If you've got curves, you've got to convert those. Whatever you've got. Also make sure you don't have lines that overlap. These are just mistakes in drawings, right? Lines on top of lines, lines that aren't really connected. There are commands. What is the command in AutoCAD? It's something like purge, isn't it? There's a purge command in AutoCAD, and it'll go through and correct a lot of the mistakes for you, or point them out, and you can. So that's a good idea. So you try and clean it up as best you can there, and then let's see if I can find it. I hope I've got it on my. Oh, I should have dropped it into that file. What a thought. I think it's on my desktop here. Okay. Let's see if I can find it. Okay. DXF file, watch it not be here. Ah, yep, there it is. And I created a folder here, right? Didn't I call the folder STAAD? Oh, golly. Oh, it looks like you would think it would not be that hard to find. Let's see. I think I can. I don't see the folder on my desk for this. Oh, there it is. Okay, so that should drop in here. DXF. STAAD1. Okay, let me. Somehow I have to redo this so it finds it. There it is. Okay, so there it is. All right, and you open that file. All right, and it asks you a little question somewhere. Oh, yeah, this is an interesting question. Which way did you draw it? STAAD likes, if you look at the icon down here at the bottom, STAAD prefers Y up. By default, AutoCAD and a lot of other people put Z up. If you read it in with having drawn it Z up in AutoCAD, it's going to come in sideways, which is, of course, a nuisance. You could, if you drew it Z up, pick Z up down here, and it would automatically convert it for you. I think what it doesn't, no, I take it back. It doesn't convert it. It rotates STAAD's axis and makes Z up. And there's a little bit, I mean, that will work generally, but you'll find there are a few commands that then don't work with Z up. So, and I think one of them is the one we use. I think area command that I use for the loading does not work with Z up. So it's a little bit of a nuisance for the little bit of trouble to rotate it in AutoCAD. So what I do, I always go into AutoCAD first, rotate it so Y is up, and then read it in. And then I can read it in with no change, and it should come in correctly. Ooh, yeah. And, oh golly, what units did I draw it in? Interesting. I think I drew it in inches. Oh my gosh. I bet I drew it in feet. It's been so long. These little questions. Oh, okay. Let's see. Let's say feet, and then we'll check it, okay? To see what that is. All right, and then it reads it in. If I did it wrong, we'll have to dump it and reread. There is a scale. You could just scale it all. Okay, there it is. If you click on one of these things, it'll tell you how long it is. Let's see. Length, 144. That would be inches. It says it's 144 feet, so I drew it in inches. Okay. Hang it. All right, let's explore the delete command. I just selected everything, and I think I can simply delete it. Yeah, okay. Is it doing it? Bang, okay. Do you want to delete those nodes? Yeah, we don't want any nodes either. Bang. Okay, sorry. All right. So we get to do this again. File, import, DXF. Save changes. No. Yes. No. Oh, whatever. Okay. Floor, open. Units. Oh, no. Y up. Okay. Units. Inches. All right. Inches, and we'll stick with pounds at first. Okay. Wow. All right. So a good thing to check when you've entered it. You know, immediately check a dimension to make sure you've got the right units in there. That would be maybe a good idea. Okay. It comes up by default in this sort of isometric view. For what we're doing, that's not really very useful. So I'm going to go up to View, and I'm going to change it. Here are the view options. This one is the top. So there we've got a top view of it. Okay, so we already checked the dimensions, the units. Okay, those were correct. When you first read it in, it's probably before you spend a few hours working on it and then discover that there was some error in the original model, it's good to check the model to make sure it's a good model. And you can do that, let's see it. Okay, under Utilities. Okay, here we go, Structure Tools. Oh my gosh. Structure Tools. And these are then that you can check for multiple structures. It comes up and just shows you one. If my structure had been separated into two pieces, like there was a beam that wasn't attached to the rest of it, it would show then two structures. You only want one structure. So that would be the first thing to check. You know, you go Structure Tools, multiple structures, and it should just say one. Okay, so we just got one. If you select it, it'll show you. That's the one we got. Okay. If you had two, you could select each of them and it'd show you which was split. And that would be a mistake. Okay, so there's one thing that's correct. Under structures, that's the only thing. Nodes, this is what I talk about. Duplicate nodes, you enter some small tolerance. By default, that's fine. Whoa. My tolerance must have been, though, what? Okay, now what? What was my tolerance? I should have looked at it. Well, that's very small. And it's saying I've got a duplicate? 64 and 101. Where are they? Show node coordinates. Oh yeah, maybe I do have duplicate nodes. Wow! I thought this was a cleaner model. Look at this. How'd that happen? Okay, well, apparently I do have some duplicate nodes. Let me see. I'm curious where they are. Before I merge them, I'd kind of like to see 27.0 and 27.0, essentially.
Red one at the bottom by the...
Oh, here it is. Oh, there it is. They marked them. I couldn't see. I was looking up here, but okay, there it is. Down there, right. Okay, well, all right. We definitely don't want two nodes, so you would merge them. Select the mode to delete. Delete the first node in all set. Delete the second node. Okay, let's get rid of the second one. Okay. Yes. Okay, so that got rid of it. So now we've just got one there. Hopefully it's still connected to the beam. But that will check too. Okay, so what else we got with nodes? Orphan nodes. These are nodes that would be not connected. Okay, we don't have any of those. Remove orphan nodes. Well, we didn't have any. Node to node distance. Yeah, you can add that dimension, but we don't want to do that right now. We don't want to look at the dimensions. Okay, and then beam tools. Duplicate beams. What? How did I end up with all this? Maybe did I enter it on top of itself or something? I don't know. Okay, but this is definitely not right. It's showing them to us. It looks like all these joists were duplicate. Okay, we want to merge them. If I gotta go down and say each one, remember to keep. Okay, I think, can I not just do all of them? You are kidding me. I've got to do these one at a time. Merge. Okay. Sorry. Yeah, I think I do remember doing this.
Can you like shift click and select?
No, I don't think so. Let's try. It'd be worth a try, but I don't think you can. I think I remember doing it. Yeah, see, it won't let you. Yeah, I remember doing this before with some. Okay, I don't know what happened to our model. I'll tell you what. I'll go back and I should have looked at it in AutoCAD first, and like I said, and cleaned it up. But I thought I had. I guess I grabbed one when I loaded it up there that was not the best, huh? Okay, well, we gotta get rid of them. And it doesn't really matter which one you get rid of, because we're going to renumber them all anyway. So, just whatever it gives you by default there is fine. Man, okay. And there apparently is no way to do this faster. But, okay, we're getting them. Okay, hooray! No duplicate nodes. Well, beams. Okay, good thing we checked it. All right. Okay, so we got that. What else is with beams? Zero length members. And here again, a tolerance. No zero length members. Hooray! Okay, that at least, that would be where you had a beam and the start joint and the end joint were specified as the same, which is obviously a mistake. At least we didn't have that. All right, what else we got here? Overlapping. Oh, yeah. No, none overlapping. Okay, that's good. What else? Beam incidence. No, we don't need to do anything with that. And this is also dimensions of beams. Okay, whew. Well, good thing we found that command. Way over under utilities. How could I forget that? But at least I remembered where it was, up in the corner. Okay, good. So we got a good model now. Now we can go ahead and start to set stuff up. Really, you can do this in any order. And what it does, as you go through it, it builds an input file. The way this used to work back in the day, there was not a graphic interface. You just sat down and typed the input file. And believe me, that was kind of painstaking because you had to have, there was no input geometry. You had to type in the start and end modes of everything. So you had to have, a list of your drawing and where all the coordinates were. Well, now it's much, much easier. With all these menus and the graphic interface, you don't have to deal with that text menu. But it does still exist, if I can find it. Whoops. Oh, okay, let's go back to under Utilities, Command File, which for some reason is not lit. Oh, because maybe I've got... okay, wait a second. Let's save it. Where's my save? Is it not giving it to me? File. It should come up with a menu. Okay, here's the problem. I had a menu open over here. Okay, the little save. It pops up little windows over where you can't see them. Okay, save. All right, now let's see. Now command files. See, it wasn't highlighted before. So I think I had something open over there that was preventing it. Okay, command file. Now it should open it. There we go. And this is the file the input file that you're building. So far we've imported the geometry. So here's node 1 goes from 0, 0, 0, or what is at 0, 0. Node 2 is at 120, 0, 0, right? So you can see all your coordinates there. Member incidences is a connectivity. It's connecting node to node. So member 1 goes from joint 1 to joint 2, or node 1 to node 2. Member 2 goes from 3 to 4, like that. So this is all as we build, that's all there is in there right now. But as we build more information, it all gets stored in here. And to be honest, in the end, it's much easier to come into this file and edit this file than to try to go through the graphic interface sometimes, depending what you want to do. But it's good to know this file's there. Oh, I hope I exited that correctly. I think I did. Okay, so supports. Let's do supports first. Okay, we'll make sure it's held up right. You see, I clicked that and it came up here on the side, right? And you go through this process. It brings it up on the side. Then you have to create it. Then you have to apply it. It's usually a two-step process like that. Create it and apply it. So first we want to create a support. So here's a create. And let's start with a simple pinned support. By default, it's going to restrain the XYZ, right? It's held, but it's not restrained in the moment. Okay, so we add that. There it is. Now, I created it, so now I'm going to apply it. To apply it, I select it, and I have some options how to apply it here. Use cursor to assign. Okay, that's a good idea. Let's just put it right there in the corner. Okay, and assign. Now I have to do it. Assign. Yeah. Specified nodes. Yeah. Okay. It did it. Node number 1. So there it is. And there it comes up with a little icon of that holding it. Now, I could go ahead and put pins on all of them, right? But that would be a little bit of a mistake. Just when you do simple beam analysis, right? We do it like that. We let one end roll, because if we don't, when it deflects, see if we can do this, right? That end moves. It's deflecting, it pulls in a little bit. So if you don't, I mean, it's a very small amount that it pulls in. In real buildings, that's just taken care of. There aren't real rollers everywhere. It's just the slippage in the joints, in maybe that the column moves a little bit. You know, in a wooden structure, it's just the nails are not that secure. It moves a very small amount, but it's not held in tension, right? So if you don't, if you put pins everywhere, you'd suddenly have, when you loaded it, those would all go into tension. It would be like a trampoline. Okay, so that's not what we want. We've got to give it some releases. We've got to put these rollers on it, and we've got to do that in the right direction. So here, if you have to imagine this whole thing is a sheet, right? And it's going to, I held it down here, and it's going to deflect, right? And as it deflects, it all pulls in. So it's almost as if, you know, I've got the floor and I shrink it. You can imagine it shrinking. If I held it at this point and let it shrink, then imagine how it's moving. Okay, this point's moving in X and Y. If it shrinks, this point's just going straight down. This point is just going straight across. So these bottom points just have that release. These edges have this release. That would be Z. And the others have Z and X, both. So we gotta create these guys. Create, and that would be these fixed butt, and then we've got to give it the release. So this vertical one here, that's the Z direction. So let's get that guy first. Okay, so fixed butt Z. So we'll let Z move. Okay, add that one, and then I could I could go ahead and, before I forget where he goes, go ahead and put him on. That's this guy up here. He's moving straight down. He's the only one that's moving straight down. So assign to selected nodes, good. Assign. Did I hit assign? Assign. Oh, yep. Okay, yes. Okay, so there he is up there. And you can see, it's kind of a wacky icon, but that blue part is supposed to be telling you that's the direction it moves. That's the direction it's fixed. Okay, now let's make one in the other direction. Fixed butt. This is the X direction. Okay, FX. Okay, add. Okay, there's number 4. This will be, oh, where are these columns? Looking on here, here's a drawing. There are 2 columns in that direction. There's one here, and there's one over there. Now look what happens when I pick them. Whoops, the other one disappeared. Oh, now that one disappeared. So what you've got to do is you hold some key down, and I think it's either the shift or the control key. I kind of forget which one it is. Let's see. It must be the control key. Okay, hold the control key down, and there we go. Okay, we got both of them. Okay, so that lets you pick 2. Then you say assign to selected, assign. Okay, good. That gives us those 2, number 2 and 5. Okay, and they show up there. Okay, good. And now the other ones that are held, we got a guy up here and up here. Those are the only 2. They will be going in both directions. So we gotta make another create fixed butt X and Z, right? X and Z. Y is up, so we don't want to release Y, then it'll fall. Okay, and you don't have to worry about the moments either. Even though it is pinned, when I attach to it, I'm going to have beams that have pins in them. So it's much, if you have the pins in the beams and the pins in the support, you'll have a double pin, and then it gives you problems. It says it's unstable, even though maybe it isn't. And it'll fix it, but it's better just not to do that. So really the only ones we want to release are the forces, that's the way you normally do it. Okay, so add, right? And then that was number 5. Assign with our cursor, what did I say, control key. Did I get them both? No, didn't look like it. What the heck? Come on. Click. Okay, now we got them both. Assign to selected, it says. Assign. Oops, look at that. Where did it jump? Okay, assign to selected. Assign, yes. Woo! Okay, we got it. 4 and 7. All right, so step 1. We got all the sports done. That's good. Now, let me see. I might even follow this tutorial. What was the next thing I did? Made groups. Oh, okay. This is kind of an optional thing, but it makes keeping track of your input a lot easier. What you do, you can take a series of members and put them together in a group, and then you can just always refer to those series of members by the group instead of always select. So we're going to deal with that quite a bit. Look, we got all these rafters, we got all these joists. Rather than always going click, 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 or however we do it, and having a whole list of rafters, it'd be easier just to one time define all the rafters and then always just refer to them as the rafter group, right? And we can specify the rafter group, what it's made out of and everything. It also makes it a lot easier to read because it'll come up in the file, it'll say rafters, and then it'll say 2 by 10, rather than a whole bunch of numbers that you don't know what the heck they are, 2 by 10. So that's probably the best thing about it. It makes it much easier to proof it afterwards to make sure you've done it right. Okay, so create groups. Oh, now where the heck is that command? Utilities. Everything's under utilities and I forget. Okay, utilities. There we go. Here it is. Groups, right there. All right, so let's select on the group. Under utilities, I pick group, and then it comes up with this lovely little menu. And the group name. What groups are we going to name? It lists in here a whole list of them. I have rafters, joists, beam 1, 2, 3, 4, 5, 6. Okay, so let's just do that. Let's say, and I don't know if this comes up in all caps or not. No, let's make them kind of like things in all caps maybe. Rafters. Okay, so I got it. Rafters. Rafters are not nodes. Rafters are beams, okay? They're individual members. The whole member, this is just one member, right? All the way across. So that would be a member as a beam, if they call it beam. Okay, so that's good. And now it's there. I could select it. Okay. It's not the whole view. I want to associate it to a list. And I could just go down and pick these all, but I believe I can do this with a box. I believe I could. What the heck? Normally, look at my cursor. See what it's got next to it? Can you see it? It's got a little dot. There are separate cursors for nodes. Right now I've got the node cursor on, and if I select, I get nodes. But I cannot, with the node cursor, I cannot select the beam. Isn't that a pain? Okay, so you've got to go change your cursor, and that is maybe, if I can remember where the heck that command is. Oh, golly. There is a cursor command. What the heck? Select. Oh, yeah. Select. Okay, select. And right now I'm on a node. I want to select beams. So I select beams, and I come back down here. Let's see what I got. Yep, I can now select beams, and I hope it'll work with a box. Bang. Okay, so I selected all of those. And it says associate to selected geometry. Okay, that sounds good. associate. Bang, it fills my list in for me. That's good. Okay, so far so good. And I think that's done. I think we got it. So that one's specified. I should be able to like turn it off and then select it and say highlight, and it should show it to me as a proof that I did it right. Okay, so that looks good. We got it. Okay, so now let's create another one. What were they? Joyce? Okay, Joyce. We said they're also going to be beams. Okay, it comes up. We select some Joyce. Make sure you don't get that end one. All right, those are the Joyce. And I think I can again hold the control key down if I can do this with two hands. It's a bit tricky. Bang. Okay, so there are the Joyce. I think that one was a Joyce. Beam 3, yeah. It even included that. It's a little bit screwy. I mean, in truth, this one should be a framing beam, but okay, we just have it in there as a Joyce, so we'll leave it like that. Alright, so we got everybody selected. Associate to selected geometry. Associate. Okay, good. So we got it. So we can check it just to make sure. Highlight. Yep, we got it. Okay, all the Joyce. Okay, create. What's this? Beam 1. Where is beam 1? Oh, up there on the top. Okay, there's beam 1. Now, beam 1. Oops. Huh. Let's see if this. I think it may work as geometry because it's one beam, but it's a. Let's try beam. Let's see if it works as a beam. If I'm wrong, we'll do it again. Oops. That's in the way. Wait a minute. Okay. There, I created it. Alright, get this out of the way. I'm going to try to select it. There it is. Oops, I got one too many. Oh, no, I didn't. Alright, that looks good. I think I got the right ones, right? Look good. Associate. Okay. Maybe we got it. Highlight. Oops. Beam 1. Highlight. Yep. Okay. Alright, that worked. Good. Let's create another one. Also be a beam. And it'll be beam 2. Let's say beam 2. Okay, somebody better click that. Beam 2. Okay, there's beam 2. Where's beam 2? The one below it. Okay, so we gotta select it. Got it. Associate. Okay, we got it. Okay. And then create another one. It's going to be a beam. It's going to be beam 3. Okay. Beam 3. I think we got. Beam 3 is the one on the very bottom. Okay, let's see if we can get this guy. Got it. Associate. Create. Okay, that's good. Create. Beam. Did I hit that? Beam 4. Okay. Whoops. What? Beam 3. How did I do that? Okay. Thought I said 4. Okay, and 4 is over there. Oops. Okay. Got it. associate, create, whoops, yeah, this is a new one, theme 5, one more to go, theme 5, I get it, good, 5 is where? Must be this one. Come on. Cursor doesn't always work. Okay, got that guy. Associate. And the last one. Oh, hooray. Beam 6. Okay. Got it. Beam 6 is, I guess, this guy here. Well. Okay. Associate. Good. Okay, so we got them all. So those are all the input. Now we'll be able to specify just by those names, which will make things life a little bit. It's a little bit of pain to create all those, but makes life a little bit easier otherwise. Okay, so we got all that. I think, let's see. Yeah, I was going to say, I guess I can just close that. I don't need it open. Now we want to specify end releases. Okay, where are those? Those are under properties or where specifications? Okay, specifications. Okay, so these are different things you can specify. We're going to look at the beams, and it should, these are all, you can make things tension only, you can make them have fireproofing, you can make them trusses, you can make it cable, all these different things, compression only. All we want to do is set this start and end and make it the release. So it came up by default as the release. There's that. And that's the one we want. And we'll initially, remember that's a two-part thing. We got to create it, and then we got to apply it. So we create the end release, then we apply it. So I'm going to create a start. Oops, sorry, I didn't select what's being released. The release, now on these, the release is the moment. It's the bending, and this is on the coordinate system for the member itself. That's not the global coordinate system, because members are on all different positions. It'd drive you crazy if you had to specify. You have to specify it by the local coordinate system for the member, and that is specified. X is the length. And then Z, I think, is the direction across, and Y is up, would normally be up. So your major axis is the Z axis, X is torsion, actually, and Y would be the weak axis. So what we want to do is we don't want to, actually we don't want to release normally you don't release this, or else if you released it at both ends, the beam could potentially spin, right? So that's probably not what you want. That would be X. Let's get Y and Z. Those will be the two primary axes on the cross section. Okay, so now I can add it, right? All right. And then I can do another one for the end, as long as I'm at it. Be the same. Okay, so there we got start and end. Now we can apply those. Let's put the starts. First off, all of the joists and all of the rafters, right? So, one way to do this, you can type in joists and rafters, but I think you have to put an underscore in front of it. Or what might be easier, where'd that group thing go? Or was it? You could do them like this. You could select them here. So there I've selected all those. And then I think I can even do them separately. Let's see. Assign to selected beams. Okay, so there are all the rafters. I could assign it to all those. Let's see if this works. And there they come up. You can see them, right? Bang. And then let's try joists. Highlight the joists and assign to selected beams. Assign, and it should add them. So the original ones are still there. I just added all those. Now, if I do beams, I'm going to have a problem with most of them, right? That's going to put a joint at every little, because this beam is all little pieces, right? And it'll put a hinge, it'll turn my beam, instead of having a beam, I'll have a chain, right? It'll be all these little links. So I can't do that to these. Instead, I have to pick where they're going. And I also have to think a little bit about how many I want. If I've got a member that's got a pin on it, and I bring another member into it, if I put a pin on it, I'd have two pins together, which will give a little bit of an error in a finite element program. It'll be an instability. In STAAD, they automatically correct that. They'll give you a warning that says you have two pins together, or actually, I think it says joint instability or something, and then it corrects it for you. But rather than make the mistake to begin with, we could try not to do that and just always have always have one that's not pinned. Okay, so let's see. I'm going to go ahead and put, and the other thing, look at this. When I hover over it, it should change color. But you just have to hover. You can't, that's such a pain with this thing. There, do you see it? If I click it, it's trying to click it. I should be able to hover over it, and it shows me a color. There. Green is start, blue is end. So start would be here. That would be the wrong one. Come on. It works very easily when you have a regular mouse. I don't know. I don't think I can bring the regular mouse. Oh, yeah, I can. Okay, there we go. So start is the green. So I do want that one. I do want that one. Let's see. Maybe I'll go ahead and assign it. Assign to selected. So I can get these, keep track of them as I do them. Okay, so we got that guy. This one would be a second one. We can leave him off. Down here we could have, oops, that's, I think that's, the start was the other end. This one, oops, start was the other end. This one, it's probably also start the other end. All right. Okay. So let's go with that. Let's then go ahead and do the ends. If I missed one, you can always come back and add it, and you can see which ones you've done, right? They're nicely illustrated there for you. Let's do the ends, and we'll select again all of the rafters, highlight, add those guys in there. Okay, there's got the other end of that, all of the joists, highlight those, assign them to, okay, we got all the rafters and the joists. Now, the ends, was this one an end? Let's see. If I assign it, I kind of hate to assign it because it's a little bit of a pain. You could, to remove it, you have to then go in and separately remove it. So let's make sure we got it. Yeah, that is that is the end. The blue one was the end, right? So, all right, that is correct. All right, let's see. Yep. Oh, we got it. Okay, so that's correct. And this one, if that's a blue, oh, I think it is. Assign that one. Okay, that one's correct. This one I thought was also a blue. Yep, that one's a blue. Okay, so let's get that guy. Okay, yep. All right, now, so who are we missing? Here we got one pinned, one not. That's fine. This one we got two not pinned. If you have two not pinned together, that's a problem because then they'll be fixed against each other. So you do have to release one of them. So let's do that guy. Okay, and who's at that end? Nope. Oh, that was a... Oh, but we've already got one released there, so we don't need another one there. All right, we got that. Who's this? End. Okay. Assign. Whoops. Come on, did you do it? Assign. Yes. Okay. So I think I've got it, don't I? There's one released. That's this release. That's released. That is released. That one doesn't need to be. That one's got one release, one release. Okay, I think I got them all. Whew. If you make a mistake, it's very easy to detect the mistake after you analyze it, because what you'll do is you'll look at the moment diagram, and you'll see the moment on the end, right? Instead of having a moment diagram that looks like that, you'll have a moment diagram that looks, have that fixed end on it, right? And then it'll, I don't know, whatever it does. It would have a fixed end. So you'll see it spike up there. It'd probably go the other way. I don't know. Whatever it does, it would have a moment shown at the end, and you'd know that was wrong. And then you'd go back and correct it back. I think we got them all. I think we got it now. Okay, so that's our releases. Oh my gosh. It takes forever to go through this. Properties. Okay, the next thing will be the actual material properties. So let's go to properties. And here you've got to, again, select the properties and then apply the properties. And the properties, fortunately, come out of a nice little database, which I thought I clicked. Come on. You don't come up? Looks like it's working on it. Okay. So here you've got steel, cold form steel, timber, and aluminum, right? For all these different countries. See, you could do German steel by the DIN norm, all these different steel shapes. For timber, we've got all this, this is all glulam, it looks like. Oh, I've got glulam accepted. Here's all the different ones. If we wanted to do hem fir, we would come up with all the possible hem fir sections. And it's a huge list because they give you the species, and the grade and the size. So there's a separate listing for every combination of that. So that gets to be a pretty big list. For our little glulam guy, it says here we want a GLT is glulam, and the combination symbol is 24FV4 Doug fir. Okay, 24F. So you go down the list a little bit. There's 24F V4. Ah, man, how nice! Right at the start of the list. Okay, 24F V4. So I get that. Now I've got to give it a size. Ooh, because each of these is specified not just by the species, but it's a complete member specification. So what have I got? I don't have my calculator with me, but you've got to make some estimate of the size, right? And this is just like when we did it by hand. You got to somehow guess it. 90% of the span in feet is inches. That's as good as anything, I think. The span is 24. 90% of it must be about 20. Right? Somebody can check me on this, or 21 or something. So that would be 20-something inches deep. Now, you want to pick one that's actually a size, right? Don't just pick some random size. Okay, so we want to look up actual size. This is for Western species, right? So if I go in the supplement, Western species come before. And I'm looking here in Western species, and it looks like we got 19.5, 20, or 21, either one of those. So we could go, well, let's go with 20. Okay. So we'll make the size here 20 by 5.5. Okay, and I think that meets that's probably about what is that, a fourth of 20, something like that. That's about right. Did I put the 5? 5.5. Okay, so that gives us a size, right? We could get maybe a little bit more accurate with the density if we want. By default, it comes up 25, which is pretty good for wood. We could go back in the table here for, oops, that is bending. All right, these are the glue lam tables. Look up what we have, 24F. Oh, here we are. 24FV4. It's right at the top of the list. So on page 65, I read across and it says specific gravity is 0.5. So that would be 0.5 times, what is it, 62.4 or something? So, yeah, 62 would be 31. Yeah, we could make it 32. How about that? 32 should be safe. That would be the dry weight. It's probably actually a little bit heavier than that. Tell you what, we could make it, let's make it 35, because that would include a little bit of moisture. Let's make it 35. Sounds like a more even number. Might show up in a table somewhere. Okay, so we got that, and we simply add it, and when we add it, it comes up over there. Okay, I think we're going to have to stop here. We've kind of gone over our time a little bit, but we'll continue. Now, the next thing to do to that, I've specified it. Now I've got to apply it to the members that are all the glue lam members. I could make the glue lam members different sizes, but for this initial shot, I may just let them all be the same size, and then let STAAD tell me what size they really are supposed to be, because it will do that. It will size the glue lam. Okay, we'll stop here, and then we'll pick up on Thursday and go through the rest of this. If you can, go ahead and download the software, and you might try to work through, if you've got time today or tomorrow, work through as far as I've done it, and then you'll kind of be up to speed with it. The project isn't due until after we come back from vacation, after, what is it, winter break. So there'll be time. You could do it over break, or you could do it that week after we come back, and there'll be time to ask questions and get that clarified. If you run into problems with this, that'll be okay. All right. See you on Thursday.